All right, well, welcome everybody to our April Fireside Chat. Tonight, the theme is laminated root rot. And if you are new to our Fireside Chat, this is an hour-long event. The first half hour is going to be a presentation. The second half hour, we open it up for either questions or for attendees to share their own anecdotes. As we go through the presentation, if you do have questions, you're welcome to put those into the chat at the bottom of the screen. And when the presentation is done, Lauren will filter out those questions. We'll answer those or try to answer those first, and then we'll open the floor again for open conversation at that point. So. I had a lot of fun with this topic. As a practicing forester for the past 30 years or so, I have dealt with laminated root rot in numerous forests. Have it in my own family's forest, and so have a very personal relationship with this fungal pathogen. But this gave me a chance to do a little more research into the disease, as some people call it, such a negative connotation for an endemic fungus that's plays a significant role in the ecology of our Northwest forests. And so I learned a few things that I hadn't fully understood before, and I'm looking forward to sharing some of the research findings as well as just some of my own anecdotes. So with that, I'm going to share my presentation here. Okay. And just to confirm, Lauren, is that working?
Oh,
Yeah.
sorry, my audio is off. Yeah, that looks good.
Okay, awesome. All right, well, let's unravel the riddle of root rot. What I want to start with is there we go, nomenclature. So, uh, what we commonly refer to as laminated root rot is a native fungus to the Northwest. This is not an introduced fungus, and it's in the family Hymenocataceae. And I can't tell you how many times I had to practice that for that just to roll off my tongue, but I think I pronounced it correctly. And Hymenocataceae is kind of an interesting Latin word to break down. Hymeno means skin, and Cataceae means parasitic, because the vast majority of the species within the Hymenocataceae family are saprophytic. That means that they feed off of primarily dead or dying wood, hence the Latin Cataceae or parasitic. I'm not entirely sure what the hymeno refers to, but probably the kind of hard skin around the conchs that typically form on trees um, that these particular fungi produce. For those of you that are familiar with laminated root rot, and if you go back a ways, we've commonly referred to this by its former name of Phelinus wirii. And if you talk to a lot of old time foresters, they'll still refer to laminated root rot as Phelinus wirii. But in the early 2000s, researchers discovered that there were two different, well, there's a whole slew of Phelinus species out there, and they realized that there was a Phelinus species that was attacking western red cedar, as well as a Phelinus species that was attacking Douglas fir. And when they looked at the genetics of these two fungi, they found that the genetics were distinct, and so they named a new species of Phelinus, Phelinus sulphurescens, and assigned the Phelinus wirii specifically to the fungi that is affecting cedar, and named the second Phelinus, Phelinus sulphurescens, as the form of Felinus that attacks Douglas fir. So in I think it was about 2010 or so, we changed the name from Felinus weiryi to Felinus sulphurescens. What's interesting is the name Felinus means conch, and the laminated root rot fungus that both attacks Douglas fir and cedar actually rarely ever produces a conch or any kind of fruiting body. And so maybe that kind of that finally bothered the mycologists enough that they said, there's something up here with this. Maybe these two species of fungi aren't necessarily related to the other Felinus species out there. Let's take a little closer look at it. And so they dug into the genetics a little bit more, and sure enough, they discovered that this particular genus was a unique genus, distinct from Felinus. And so they renamed it Conifera porii weiryi, the cedar form, and Conifera porii sulphurescens, or the species that attacks Douglas fir. So today, when you talk about laminated root rot, if you're at a party and want to sound smart, you have to refer to it as Conifera porii sulphurescens and no longer Felinus weiryi. So there is your Latin binomial nomenclature factoids for the day. I'm now going to move on to words that are a little easier to pronounce. So let's get into the biology of Conifera porii sulphurescens. So it's still a saprophyte, but kind of, not entirely. So the laminated root rot can actually live on and infect live trees, so it's not entirely dependent on dead trees for its host medium, and it exclusively spreads, or I shouldn't say exclusively, it primarily spreads by root grafting. So the roots of one infected Douglas fir need to come in contact with the roots of a non-infected tree, and then there is a penetration of the root bark by the hyphae of the fungi, and then they infect the new tree. Rarely does this fungi infect dead wood. However, once it kills its host, the fungi can continue to live on the decaying and dead wood for well over 50 years, essentially until that medium or that inoculum decays sufficiently that it can no longer serve as a host medium for the fungus. So a question that I was not able to answer in the literature is, we see these old growth stumps in our forests that have been there for 100 years or so. Can this fungus continue to live on that medium, for 100 plus years? And it seems that the answer is yes, that as long as there's some kind of solid substrate for the medium to live on. But with most of our second generation, third generation trees, when we cut them, those stumps typically rot and dissolve into nothingness, within 50 years or so, since they don't have the same kind of resins that preserve them like old growth stumps do. The other thing is that this fungus can colonize young and regenerating trees. So, in an older forest or a root rot pocket within an older forest, as the canopy begins to open up, the dominant trees die off, and there's a flush of new regeneration of younger trees, specifically Douglas fir, the primary host for this fungus. Those young seedlings, again, when their roots come in contact with the either the dead wood, the stump of a former tree, or the decaying matter of a former tree, or an infected live tree, those young seedlings can also become infected. And that's why we often refer to this disease as a disease of the site, that it can persist in a particular area in the forest for one paper estimated well over 400 years. They identified a clone within a forest, and I don't know how they did. Maybe they asked its age or something. I don't know how they determined how old it was, but they estimated that that particular clone was over 460 years old. So persisting on that specific site for nearly 500 years. So the main tree species that are susceptible to this particular genus, again, Coniferporae sulphurescens, is Douglas fir, um, but also all of the true firs are quite susceptible. That would be grand fir, noble fir, silver fir. And then western hemlock is also susceptible, but less so than the true firs and Douglas fir. So a little bit of identification. I'm just going to share the visual clues to laminated root rot in the forest. Uh, Usually the most common way of identifying it is by observing a patch of dead Douglas fir. And if there's no other discernible reason for why 3, 4, 5, a dozen, maybe more Douglas fir are all dead, uh, usually my first assumption is probably root rot, although I don't want to solely assume that. There can be other reasons for mortality as well, but that's usually the first clue. There's just a distinct cluster of dead Douglas fir. Um, if the trees are still alive, they haven't completely succumbed to mortality yet. If you look up at the live crowns of the trees, you'll see that the needles are often very thin, often referred to as a weak crown. You can see through the crown, whereas a healthy Douglas fir should have a full, lush crown that's not porous. Another clue is heavy cone sets. So these trees are stressed. And a stress response, one of the stress responses in trees is to put on a cone set in order to begin replicating itself. And so if you see a particular tree that is putting on a heavy cone set year after year after year, that could be a clue that that tree is infected, because typically trees will only put on a cone set every 3 to 7 years or so. The other is that laminated root rot tends to weaken the roots of trees and makes them susceptible to blowdown. So if you find some blowdown in the forest and you notice that the roots on the root ball are very abbreviated, like this picture shows, in other words, there's not long strands of roots hanging off, but they're abbreviated stubs, that's usually indicative of root rot, because root rot will make the wood structure of the roots very weak. And so when the tree pulls over, the fine small roots usually have already rotted in the soil and don't come up with that root ball. The other thing is when you take a look at the wood structure of those roots, you should be able to grab that root and literally just pull it apart like almost like a woody sponge or so, and you'll see white specks in there, and you'll see the delamination of the growth rings of the roots. Much like this picture here, hence the name laminated root rot, although I think they should call it delaminated root rot. And then the last is if you're cutting live trees, root rot imbues a very characteristic stain in the stump of the tree. Kind of looks like a Rorschach blot, and anybody can take a look at that. And maybe this should be another form of psychoanalysis. What does that look like to you? And that stain typically only goes up about 3 feet into the bole of the tree. That's about as far as the fungus will climb up or feed up into the tree. It really stays very localized to the roots and the base of the tree. Let's talk a little bit about the occurrence and spread. So interestingly, root rot can occur as just a isolated incidence, just one tree infected somewhere in the forest, tree here, tree there. Somewhere along the way, it picked up the disease, maybe from an old stump. But typically, like I mentioned, it occurs in clumps or in an aggregated fashion within the stand. And most of the mortality that we see just by percent of trees that are dying within a forest tend to occur in these aggregated areas. That's for a number of reasons. The fungus has gained a very strong foothold. It's usually spreading in kind of a radial or fractal pattern out from a point of infection. and so it's infected numerous trees, and so the mortality is higher in these aggregated areas, and just continues to add to its hosts. And then this is one thing that I learned, is that it can again transfer from dead wood to live trees. So it's not spread solely by root grafting. So again, if there is a stump or some roots that are infected in the forest, and live roots come in contact with those dead roots or that dead stump, that fungus can carry into then the live roots of that tree. But otherwise, again, it typically requires root to root contact to spread from tree to tree. And the other thing that I found really interesting, because I've always wondered this, and I've always been asked the question, how rapidly does root rot spread from an infection point? And it actually spreads typically, on average, very slowly, only about a half inch to at most 4 inches per year. Now, that's the average. In some of the research of these root rot pockets, they did find that in areas where there is a vigorous infestation, and it is spreading rapidly, that on those vigorous sites it can spread upwards of nearly 3 feet per year. But again, the average is typically much, much less than that. Now, what's also interesting is that there are other saprophytic fungi out there, in particular armillaria, that are much more aggressive and can serve as a control to the laminated root rot. And when a tree dies, or so let's say it's cut rather, and that stump is there, it's much more likely that that stump will become infected by armillaria than it will laminated root rot. The armillaria can spread by spores, and I didn't mention this earlier, but because Conifer porei does not produce a conch, it does not spread by spore. It solely spreads again by root contact or below ground. So again, we cut a tree, there's a stump, you've got an open wound on top. The spores of armillaria will get in there. It's a much more aggressive saprophyte, will colonize that stump and can kind of fend off, if you will, the laminated root rot. And then, as I mentioned already, that post-harvesting of root rot patches, if it's replanted with a host species, Douglas fir, true firs, or hemlock, those will fairly readily become infected by the disease. However, another thing that I found that was very interesting is that vigorously growing trees are just as likely to be infected as weakened trees. So a tree may be weakened because of environmental factors, droughty soils, perhaps beetles, what have you, maybe other fungal pathogens. But this has been kind of a long-held misnomer that if trees are healthy and vigorous, their immune systems are strong, they'll be able to resist laminated root rot. And in the studies, the literature says that that is not the case, that root rot will just as readily infect a healthy, vigorously growing tree. So some of the effects on the tree, here's what root rot does. It kills the phloem and cambium of the roots, and it initiates decay in the xylem. And the xylem is the portion of the tree that is moving water and nutrients. And so you can see then how this fungus can reduce the vigor of its host by reducing the ability of that host tree to transfer water and nutrients up into the bowl. And it really prefers the early spring wood when the tree is growing fastest, because the cells of that spring wood are much larger and the cell walls are much thinner, making it easier for the hyphae of the mycelium to penetrate those cell walls and infect the sapwood. And as I mentioned earlier, rarely does that disease carry much more than 3 feet up into the bowl. The effect of root rot on a tree is that the growth rates of that tree slow down, and diameter is affected more than height growth. I'm not entirely sure why that is, and didn't have a chance to really dig into that, but I'd be open to anybody theorizing. And then it can take several years to kill a younger tree, but it can take decades to kill an older tree. And this is something that I've definitely observed in the woods when I come into root rot pockets, is there's still live trees within a root rot pocket. And when I'm in older stands, there are still, where clearly root rot has been there for decades, oftentimes there still are older trees that look perfectly healthy. So I think this is another place for research is what allows one particular tree to, in essence, fend off the disease or at least not succumb to mortality before a neighboring tree does. Is it genetics? I'm sure we could unravel that mystery at some point. But um, and then again, overall the tree is weakened, including the roots, and this can increase susceptibility to other disturbance agents, beetles or blowdown, since the roots are weakened. And then in some of the research of root rot pockets showed that the rate of mortality within these areas is about 26% over 20 years. And so, if that were consistent, that would mean that all of the trees, within a particular area that's infected, would die within 80 years or so. I don't think that this is always necessarily the case. Like I mentioned, I have been in older stands that are 80, 90, over 100 years old that are infected by root rot, and there still are live, what appear to be vigorously growing trees in there, and presumably that fungus has been in there as long as those trees have been alive. But again, on average, the researchers that were looking at this found that you could expect about a 26% mortality rate every 20 years or over 20 years. And then trees usually die when they're standing, but because the roots become weakened, that can lead to blowdown during storm events. So effects on the forest. This causes thinning of the canopy in stands that are dominant to Douglas fir, as well as creating gaps in the forest canopy. And this then, of course, leads to a combination of both, horizontal and vertical structural complexity. What that means is, again, punching holes in the stand, creating some gaps at the horizontal level, as well as creating snags and other types of structures, allowing other trees to come in that increase the structural complexity on the vertical axis of a forest. Since it's obviously killing trees, we get a recruitment of snags and down logs, which can also provide forage, nesting, roosting habitat. So these types of pathogenic fungi are critical for creating habitat structures for all different types of birds and mammals. And then gradually over time, we find that these sites will convert to other species than Douglas fir, non-host species. And I'll talk a little more about what those are. And then, of course, very important for the nutrient cycling. Death and decay is all part of a very healthy forest. And this is my euphemism for root rot, that it is an agent of stand diversification. So, again, if we are looking at a rather homogeneous Douglas fir plantation that has root rot in it, my family has one in our forest near Black Diamond that's riddled with root rot. We bought the forest from Weyerhaeuser in 2014. Perfect example of a Weyerhaeuser Douglas fir plantation. And now there are kind of gaps and holes and snags and what have you forming all over in that particular forest due to the root rot. Being obviously an advocate of ecological forestry, I see root rot as an ally in this particular case in creating structural heterogeneity. As far as an investment in future timber crop, it does have me a little concerned because we are losing, I wouldn't say a significant amount, but we are losing a very valuable, merchantable species within that particular forest. But that's incentivizing me to do some other things with those areas that are infected, which we'll talk about in a little bit. So management, let's get to that. So I want to first just take off the table options that I think are impractical for small woodland owners. The first is fumigation. I doubt very many of you would be very enthusiastic about going into your woods with some kind of, I don't even know what it would be, but fumigating device and pouring chemicals essentially into your soil to kill off this fungal pathogen, as well as Lord knows how many other fungal species within your forest. So probably not a good option for us. Stump removal. So this apparently is quite effective. You come in with heavy equipment, grab the stumps, make sure you also get all the roots in there as well, kind of sift through the soil to get all of that inoculum out of the soil, and then replant again. Probably not what most of us would think about doing. Just imagine the soil compaction, soil disturbance, not to mention cost of that approach. Introducing antagonistic fungi. We talked about armillaria as one of them. This might be within our means if we can get our hands on armillaria. I'm not entirely sure how it would be introduced into a system. That's probably, and I'm sure there's research on that out there. But again, I find this to be rather unrealistic. And then the last is isolation, which typically requires very, very large patch cuts. Although, depending on the size of the root rot pocket, if it is a small pocket, maybe it's just a small patch cut. But if that root rot has been in your forest for decades and has now infected, several acres, then you're going to have an area substantially larger than that to try to isolate it. And I will talk about patch cuts, as I think it's all scale appropriate. So, whenever I talk about forest management and forest management options, you'll hear me always say, it's all about objectives. And that's where we have to be very clear. And since NNRG is an advocate of ecological forestry, that's where, again, I feel like we have opportunities to embrace root rot within our forest and look at it as a benign agent and perhaps even an ally in helping us achieve our ecological objectives. So, if that's something that you're willing to buy into along with me, then I think we have a number of different management options where we can work with laminated root rot rather than against it. And so let's go through some solutions that I think are suitable for small woodland owners. And the very first one is, hey, break out your lawn chair and watch the show. Let's just see what root rot does. If you are not that particularly concerned about losing timber production within that particular area, if you're excited by the fact of this fungi creating snags for you, so you don't have to do that yourself, etc., then you can just let it run its course. Although, as you do that, there are some other strategies to work in a companionable fashion with root rot. And I think the easiest one is planting, and planting those sites with tree species that are not susceptible to the disease. And I'll talk about that. I'm going to talk about each of these, well, actually, just the planting and thinning in a little more depth here shortly. The other is then to come in and thin that stand. Say salvage log. Take out the trees that have been recently infected, that are showing signs of infection, but the wood quality is still solid. And once you see a tree that is showing signs of infection, basically at the point that it drops all of its needles and is no longer able to photosynthesize and is arguably effectively dead, you usually have about 12 to 24 months to harvest that tree before other fungi are going to get in there, other saprophytes, and really begin degrading the wood quality of that tree. So thinning could include, again, salvage harvesting, and otherwise kind of opening up that stand to come back in and replant also. And then the last, again, is patch cutting. So depending on the scale of your forest and or the scale or size of that root rot pocket, coming in and cutting in maybe a small patch cut would be viable. And I'll talk about that again in a little bit. So let's talk about planting. So we, of course, are focusing on non-susceptible species. So we will not be planting Douglas fir, any of the true firs, or western hemlock back into a root rot pocket. But all hardwoods are immune to this particular fungus. So that could be big leaf maple, it could be alder, cherry, ash. I mean, you name it. Whatever the hardwood is that is suitable for your site. And this is where it's really critical with hardwoods. To know what your soil conditions are, your soil type, the soil hydrology, moisture levels, in order to get the proper hardwood in there. I have heard this for years and was unable to find any research that corroborated this other than numerous allusions to the fact that alder may have an antagonistic effect with the laminated root rot fungus. And there weren't any conflicting opinions about that. There just were rather obtuse allusions to this. I couldn't get at whether there's an actual, chemical or allelopathic relationship between alder and the pathogen. Some said, well, alder, given it's a colonizing species, will come into a site at a high density and shade out Douglas fir or shade out the true firs and prevent that site from regenerating with trees that continue to host the fungus. And that's a way that alder then sort of scrubs this disease out of the site. I can see that being possible. I've heard of folks using alder in a cycle, growing alder for, say, a rotation on a site in order to cleanse it of root rot. Again, these are all anecdotes, hearsay. I could find no literature that corroborated that. So the conifers that are not susceptible to this particular species, the Conifera porei sulfurescens, are western red cedar, keeping in mind that western red cedar is susceptible to a different species of Conifera porei. Any of the pines also are immune. Redwoods are immune. I dug a little deeper into it. Pacific yew is partially susceptible. They kind of put it in the same category as western hemlock, where it's partially susceptible, partially immune. And I really couldn't come up with too many other conifers that are native just to the Pacific Northwest. Yellow cedar is susceptible to Conifera porei. I'm not sure if it's the same Conifera porei as western red cedar or if it is the sulfurescens that Douglas fir. So I think before you entertain other species than red cedar, any of the pines or redwoods, you'll want to do a little more research to understand their susceptibility. And then the other thing is that as that canopy becomes a little more porous, it is, of course, going to support the growth of any of these other tree species, hardwoods or conifers that you plant in there. So that, is one perhaps benefit to that open canopy. So let's get into thinning, because this is the subject of a lot of misunderstanding. Interesting, the results of thinning are very inconclusive. I read through about half a dozen papers pertaining to thinning, and there were directly conflicting results in some of them. But in general, the general consensus is that thinning really has no beneficial outcome. There is no detriment to it necessarily. It doesn't invigorate the disease, but it doesn't at the same time improve the either the immune systems or the vigor of the remaining trees, or it may improve the vigor, but it doesn't matter since the root rot can just as well infect vigorously growing trees. And most of the studies show that there really is no net improvement to tree growth from thinning in these stands, likely because, again, if these trees are infected, they already are suffering growth rates. So we didn't see that typical bump in growth that you would see when you thin an otherwise healthy stand. The other thing is that it may increase wind throw. Again, since these trees have weakened root systems, coming in and thinning may increase wind throw. And again, depending on your objectives, that may or may not be desirable. And there are ways of minimizing wind throw by thinning lightly, et cetera. But I think, since we typically experience some degree of wind throw regardless, even when we're thinning in healthy stands, you might see a little bit more of that in a stand infected by root rot. And then one thing we still don't know very well are the effects of compaction from logging and the effect that it has on roots. It could stymie the spread of root rot, or it could exacerbate it. I could find no definitive literature or no literature that said anything definitively about that. However, by removing infected trees, we may remove some of the root contacts and therefore slow the spread of the disease. So we're not going to eliminate it, but it's possible to slow the spread by reducing the hosts for it. And also, we may create opportunities for armillaria to become established. Like I said, armillaria can infect stumps much more quickly than the Conifera porei. or those stumps also may provide inoculum for laminated root rot. So nobody really knows for sure. There's a lot of speculation around this. And I think even with thinning, again, we want to come in and plant and begin really transitioning that site. So my takeaway from this is, as ecological foresters, I feel like we still can come in and thin these stands, but we have to realize that over the long run, that stand is going to convert to other species than Douglas fir. I don't think that because if you have root rot, you need to clear cut. If that's not agreeable to you, but you do have to practice non-attachment and realize that over time, that site will convert. And as active managers, this is our opportunity to intervene in there in a way that benefits us. And again, thinning may improve the growth of the planted tree seedlings that are not of a non-susceptible species. And then again, the last strategy is a patch cut. And the general recommendations for that is you cut all of the infected trees and then you continue cutting out in a circle, either looking at the stumps to see, okay, now I've finally cut a stump that doesn't show that Rorschach blot of stain in there. And then you cut another 50 feet beyond the last known infected tree. And that defines how big that patch cut needs to be if you're going to try to isolate that. Because the idea, again, is to get beyond the influence of the infected roots, which is generally recognized to be about 50 feet from the last known infected tree. And then here are most of the references that I looked at. I don't expect you to write all these down. We will be posting this on YouTube, and if anybody would like, I'm happy to send you this presentation afterwards. So I'm going to leave it at that. That's it, and would love to hear from you all. So if you've got questions or your own personal anecdotes, who has root rot in their forest? Let's see a show of hands. We're the Root Rot Club. It's hard to see your hands when everybody's videos are off, but whatever. You can raise your hand in Zoom fashion. Yep, Kit's got it. I know that. We just planted a 10-acre root rot pocket in her forest. About a month and a half ago or so, at most. All right, so let's see. Lauren, are there any questions in the chat? Let's start with that.
Yeah, there's no questions, but Scott posted a link. He said that here's a link to a fantastic guide to common diseases, fungal pathogens, and insects affecting PNW conifers. And it's USDA.gov.
Great. Thanks, Scott.
Yeah.
Okay. Well, if there's no questions, I'd love to hear from folks. Either, or what kind of strategies are you using to address root rot, or does anybody have any other information that they care to share that could complement what I shared?
I have a question of somebody who has absolutely no information beyond what I just learned. But I'm wondering, I bought my property, my forested property, after it was clear cut, and it's now regrowing a young Douglas fir plantation, I guess, which I'm slowly going to hope to diversify. But I'm just wondering, would I know already if there was a problem with root rot, or will it be something that sort of manifests over time?
Yeah, it's a good question. So, interestingly, root rot, if the stand is younger than 30 years old, root rot typically doesn't express itself very readily. It can, but in one of the papers that I read on young stands is that it can take up to about 30 years for root rot to grow sufficiently within a young stand to gain the vigor to begin resulting in mortality. And one of the reasons for that is that, again, armillaria tends to colonize those kind of clear-cut areas, or whatever the harvesting method was. It colonizes those stumps and again, to a certain degree, fends off laminated root rot. So even though those young trees can become infected, it can take up to 30 years for mortality to begin. So how old is your stand?
It was clear cut in 2012.
Okay.
So young.
Yeah.
There is there was some trees left standing, a small, maybe 1 acre segment of it that were left. And then, individual trees, maybe one every acre, every several acres. But those were mostly the ones that were left are like madrone and other trees that weren't, I don't think, financially useful. So they left those ones. But I don't see any sign of it. But even the original stand that was left was probably pretty young as well. I don't know when it was originally planted, but it's, probably second or third growth anyway. They're not huge trees.
Sure. Okay. So one thing that I didn't really touch on as kind of a long-term management strategy, although I think it was somewhat implied in here, is obviously managing for species diversity rather than managing just pure Douglas fir plantations is one of the best strategies for mitigating the potential for root rot in your forest. Again, since this spreads by root grafting, if you have a homogeneous Douglas fir plantation and root rot is in there, it's going to spread through that stand. Now, it may spread very slowly, like I mentioned. It could only be anywhere from a ½ inch to 4 inches per year, but it's just a matter of time. And so, one of our best stopgaps or kind of control mechanisms is to manage for species diversity. Depending on again your soils and the microclimate of your site, that could include any number of hardwoods or non-host species within that stand. Anything that's just going to kind of prevent the roots of that Douglas fir, from coming in contact with roots of other Douglas fir, is something that's just going to. And if nothing else, it will help slow the spread of the disease within the stand. And I think from an ecological forestry standpoint, that's really more where we should be looking at is how do we slow the spread of the disease. And that would be if we are managing for timber production, if revenue generation is part of our strategy, then we're going to want to be looking at methods for slowing the disease within a stand. Other questions, comments, or experience from folks?
You kind of mentioned this, but what's if you do have a homogeneous stand of Douglas fir, what's to prevent this disease from just rampaging through the whole stand?
Nothing. Well, I mean, our black diamond forest is a good example of that. There is very little species diversity within that stand at this point in time. And since we bought it in 2014, over the past 10 years, I've watched root rot, spread in there. There's one very, very aggressive pocket that is about 5 acres. And I wish I would have put some plots into that to see if that, kind of 26% mortality rate is true. It's interesting because there still are perfectly live, healthy Douglas fir right in the middle of that, surrounded by dead Douglas fir that have succumbed over the past 10 years or so. But no, it will, just like a cancer, essentially just keep moving through a Douglas fir stand, albeit anywhere from ½ inch to nearly 3 feet per year. So, again, what's going to control it is if there are any, there's got to be some kind of biological barrier to that. A non-susceptible species, a stand of alder, a stand of cedar is something where the Douglas fir roots, can't get through there. But as long as there is root contact between Douglas fir, it'll spread.
So what strategy are you taking with the black diamond land?
Yeah, so we're going to be thinning around the perimeter of the stands. I want to reduce the number of trees and space them out just to try to slow the spread into the remaining Douglas fir. Salvage harvest so we can salvage some of the trees that are dying, and then replant that site. I think I'll be able to it's a rocky soil, kind of a droughty soil. So I'm going to be planting cedar from Northern California that we'll see, if their genetics are a little more adapted to a drier site. I'll be putting redwoods in there and pine. The latter two really are not a bid for a future, timber crop. We don't at this point have markets for redwood logs in the Northwest. Pine we do, but it's crappy prices, so it's more planting for diversity. And given the values and objectives of our family, having a more diverse stand is what we're aiming for. I'll be probably putting some maple in there. There's very little maple. It's not really a suitable site for alder. At least it won't produce good alder saw logs. I think alder will grow there. So I may sprinkle in a little bit of alder just to see again if it can have some kind of cleansing effect. If nothing else, it'll produce nitrogen. I did read a paper that stands that were higher in nitrogen had a lower incidence of root rot in them. So when either trees were harvested and there was a flush of nitrogen into the soil for the next, and I didn't catch how many years, it seemed to infer that the effect of root rot was lessened, or there's less of an incidence of it. And I think I was seeing some relationships between alder also as a nitrogen fixer and a decrease in the incidence of root rot. So just kind of trying a diversification strategy like that.
When you mention pine, are you talking about white pine or other species?
Any of the pines are completely non-susceptible, unsusceptible. What's the right way of putting that? Are immune. How about there we go. So again, it's going to depend on the site. What pine will do best there. If it's a droughty site, white pine, Willamette Valley ponderosa pine. I'm talking west side anyway, west side dry. If it's a little bit wetter site, shore pine or even white pine can grow on slightly wetter sites as long as it's not saturated year round.
In your travels in the Pacific Northwest, if you had to rank the top 3 fungal pathogens in terms of the impact on forests, how would you rank the top 3?
Well, the top 2 are easy. Laminated root rot's number 1 for sure. It's just the most common. It's kind of the easiest to identify out there. And then armillaria. I'm not going to be able to pronounce the species. Ostoya. That's the honey mushroom. That one can actually infect hardwoods and conifers alike. It's a remarkable fungus. I think I see it more on true firs, but I believe it can also infect maple. So it's fairly common, but for some reason doesn't. I think since it's a saprophyte, it's not as inclined to infect living trees like laminated root rot is. So the tree is going to have some kind of. It's going to have to be weakened somehow or have some kind of dead wood in it. Maybe it's a scar. That's where I see it quite often is the cat scar. After a logging project, the skidder has knocked some bark off the base of a tree. You'll often see a cluster of honey mushrooms, armillaria at the base there. And then third, honestly, yeah, Scott, I don't know. It's really hard to identify other fungal pathogens. There's a lot out there, but I haven't come across that many that have the same effect as laminated root rot and then that particular strain of armillaria.
I've been seeing the it's a German name. It's Schweinitzii. It's a type of root rot, and the fruiting body it grows in association with Douglas firs, and the fruiting body typically occurs several feet away from the bowl, and it's very dark brown, and usually, well, it can get to about 1 foot tall. It's kind of like a standing shelf.
Huh.
And I found a few around our home plot, next to Douglas firs that are large. I mean, 35-inch diameter plus. But it doesn't seem to have affected their health. I mean, they have strong canopies, and so I don't know how serious it is, but it's always a little daunting when you find, some pathological fungus growing next to your trees.
Yeah, for sure. As you're mentioning that, I do recall now working in older stands. I see this a lot in the San Juans, and in stands that are more than 70 years old. The common name is red ring rot. I forget the botanical name for it, but it's a saprophyte also. It produces a kind of a velvety conch on a tree. And it is that it, Mark? Yeah, Mark, is that the red ring rot? Schwenzii? Because that was starting. That's what jogged my memory, Scott. Was I think that may be it. And again, it typically only comes into older forests, and I don't believe it's fatal to the tree, or if it is, it takes decades to kill a tree. Because I'll see again red ring rot on these old 100-plus-year-old trees, and they otherwise look like they're doing just fine. So it's parasitic, but not. I don't think always fatal. But that's very common in older stands.
I don't see the red ring rot. I'm looking at that field guide that I put the link on the chat for, and its common names are cowpie fungus or velvet top fungus, and the fruiting body does look like a cowpie standing on edge, and it's frequently found on Douglas fir. The
Yeah,
fungus.
and also the red ring rot on Douglas fir on pine also. I'm just kind of looking it up here real quick. Red ring rot. Boy, I'm not gonna be able to pronounce that either. But if you type in red ring rot into the Google, it'll pop up. Porodalia pini.
And Mark mentioned that the one that the Phalios Schwinitzi, also having a hard time pronouncing that. He said that it's Dyer's DYER, Dyer's polypore.
Oh yeah, sure, okay. Yeah, so it's the fungus that people have used for dyeing fabrics and.
Oh, cool. Clev also had a question. They asked, in the context of a 2,500 acre tree farm or forest, what is the size range that defines a patch cut?
Well, that's entirely subjective. And you would be using a patch cut for a specific purpose. So if it's in the case of trying to isolate root rot, I gave you some of the variables. So again, you would have to be cutting basically out in a concentric ring from the infection point and continue cutting all of the obviously visible trees. And then at some point you're looking at the stumps if the tree is not expressing the fungal pathogen from a visual standpoint, the weakened crowns or dead trees or what have you, then you're looking at the stump. And then again, you cut another 50 feet beyond that. So the size of that isolating patch cut is going to be entirely dependent on the spread of the disease. So if that's the sole purpose for isolating the disease, we use patch cuts for introducing other tree species. If you want to regenerate Douglas fir, the general rule of thumb is you need a patch cut that's at least a half acre in size to get ample sunlight down into the stand to support the growth of Douglas fir, but completely different objective in that case. If it's snow gaps, we can kind of go on and on with gaps at that point. We're creating snow gaps up in the Nisqually Community Forest, and even a quarter acre in size, we've found is sufficient for accumulating snow and retaining that longer into the spring. But since most of the people we work with have 20 acres or 40 acres, a 3 or 5 acre patch cut in a stand that size or forest that size oftentimes is just not palatable for somebody on a small scale. So again, entirely subjective. Well, it's 8:30, 8:31 technically. I'm happy to hang out if anybody wants to chat a little more, have any anecdotes or questions, or but if not, thanks for joining us again this evening. And I think the topic next month we've already decided is on density management, and I'm going to be talking to you about the silvicultural concept of relative density. And I'll leave it at that. So look forward to seeing you in May, and enjoy spring.